I'm going to record here on WebEx and also on lecture 9. So you will have access to both the okay, so recording has started now, inshallah. Bismillah. So we are now in the 9th chapter, 9th lecture, which is nonlinear optimization. This was translated by some student, Namazat al-Amsal li Akhtiya. So let's continue from a quick revision of what we have done so far. We covered linear programming in the last class. So far, in operations research, we have been able to cover a good lot of chapters, contents, lot of information, and it's been very good to have your participation in both when we were taking it from the studio and now through WebEx. In fact, this one is I find this one to be a much better solution for female teaching, because we are all able to participate equally. So all the students can hear me equally, and you have many options to give your suggestions, your answers on the group or on the chat, or you can also speak, right? So I find this one to be a good way of very nice medium of communication. Yeah, you all agreeing with me? Good. All right, and I'm also thinking of a good assignment for you. Perhaps we don't know how things shape up. Maybe the final exam also will be of the same sort as let's see how it goes. So first of all, for midterm, I have to plan for an assignment also for you, which would be which should be some which involves some good research by you. You are able to find information and application in the real time, real life business problems, so that you, because we are now good way ahead in our course, and just 1 or 2 more chapters are left. Maybe we'll try to cover them. Otherwise, the course is in a good shape, alhamdulillah. So our topic today is nonlinear optimization models. To understand the nonlinear optimization, it will be easier for us to relate with our discussions on linear programming. You have all done your assignments, and I hope you are clear with linear programming. We covered 2 types of problems. We did a problem of maximization and the problem of minimization. In linear programming, we also solved manually using the graphical method to find the values of the decision variables. And once we are able to find the value of decision variables, then it becomes that is the solution. Then we can find the value of z function, that is the objective function. It may be maximization or minimization. But there was one rule we learned in the linear programming. What was that rule? In linear programming, what was the rule? When can we apply linear programming method in a business problem? Just look at the graph and tell me, what is the rule? When would you decide that linear programming can be applied to a problem? Anyone? I hope you can hear me clearly. My question is, when can we yes, graph A. So what do we how do we explain graph when the line is change? No. Can you just explain more? What does this graph mean? Line is straight, and when the line becomes straight, you are right, you are correct, that this is the graph A. We can apply linear programming, but can you explain this graph, this line? What does it mean, this line? Suppose this is time, this is distance. What does it mean? What is the relationship between time and distance? Distance equals time? No. Distance is not equal to time. Then what it is? Keep growth. Yeah, I think Najat is close. So let's take her answer. The line is straight, linear, moves in the same growth. Yeah, Vedad is more correct. Najat and Vedad are, yeah. So we can take all the answers. Linear, okay. There is a linear relationship. The relationship between time and distance, or what are these? These are variables. So the relationships between the variables are when the time increases, the distance increases. Yes, absolutely, very nice, Naval. When the time increases, the distance increases at the same rate, at the same rate. Yes, when the time is increasing, suppose it is 1 hour, this is second hour, this is third hour. Yes, yes, Najat is right. All of you are now right. There is a direct relationship. Nada is also right. There is a direct relationship, and there is a direct relationship, and the relationship, the change between the two variables are at the same rate. So when they are at the same rate, we will get a linear relationship. When we plot it on the graph, we get a straight line. Whereas in the second graph, there is a relationship. There is a relationship between distance and time, the two variables. But what we see that in the first hour, it is, say, suppose, in the first hour the car could climb it. Yeah, very good. Not at the same rate. They make a good relationship, but they are not changing at the same rate. The time increased from 0 to 1 hour, the car traveled 10 kilometers. But when the time changed from 1 to 2 hours, here it's a big change. Now the car traveled, say, 60 kilometers. Then when it moved to 3, it again started increasing more. Okay, so this is how the speed is changing. The relationship between the two variables are changing. Here it's the same. It is, suppose, in the first hour also 10 kilometers, in the second hour also 10 kilometers. So when we plot it on the graph, we get a straight line, whereas in the second graph, time and aren't at the same rate. Yeah, good. So in fact, what is the relationship between time and distance called? Speed. So speed in graph A is same, whereas in graph B it's different. Here in the car is moving at 10 kilometers per hour, then it increased to 60 kilometers per hour, 70, and then to it again 60, then it increased. Suppose it's highway, and then in the fourth hour or fifth hour the car was moving at 110, 120 kilometers per hour. So this is what it is showing, that there is no linear relationship. The movement, the speed is not linear. So when the relationship between two variables are not linear, so you all understand, all of you, what does it mean? So not linear means that they are related, but they are not related, that the rate of change is not the same, then we cannot apply linear programming. Then in that case, there is another tool in operations research which can be applied, which is called non-linear optimization. Non-linear optimization. So that's our topic, that what is non-linear optimization? How is it different from linear optimization or linear programming? Yes, graph 2, this one, we don't say this is non-linear optimization. This is an example of non-linear relationship, and this is an example of linear relationship. So for condition of linear programming problem, if we want to apply this method, it has to be linear relationship. But if the relationship between the variables are of this type, then we cannot use linear programming. We will be using non-linear programming method. Okay, this is not non-linear optimization. This is the example of the relationship. So this is the first test. How are we going to know where we can apply linear programming and where we cannot apply linear programming? We will have to use, yes, because it's so. Also, we can take the example of linear programming. First example was of product mix. There were two variables, number of bowls, number of mugs, isn't it? And there were two constraints. So when we plotted the constraints on the graph, they were both a straight line. They were both a straight line. Yes, the non-linear relationship takes the form of a curve. In the case of bowls and mugs that we solved in linear programming, we saw that there was a straight line of constraints, and for the decision variables also. So what happens is, in the case of a straight line, we know easily where is the feasibility region, and we can apply the linear programming method. One method was graphical. There are other methods also like simplex. So we can apply these and solve the problem of linear programming. Find the values of Manal wants to ask something. Do you have a question, Manal? Okay. So when it comes to a non-linear relationship, here linear programming cannot be applied. Suppose we change this graph. Now the bowls and mugs, the relationship between these two variables are not linear. They are not linear. So when we plot the relationship between the bowls and mugs, we get something like this and this. The constraints are like this. So when we plot a graph of first constraint and the second constraint, we are getting the relationships like this, then this is called non-linear relationship, and here we cannot apply this method what we learned in the linear programming problem. Let's move forward. So, the first basic lesson to understand is to learn the rules of linear and non-linear relationship on the curve. This is very basic and easy to understand. We all have learned in very basic school, in 10th standard 10 or even before that. Okay, so let's move forward. Now, even though the relationship between the variables, they may be the relationship in the form of constraints or in the form of objective function, the relationship on the graph are non-linear, they still are similar to the linear programming, not just linear programming, but it's called, we have already learned the general OR model. So, what we learned there? We learned that in general OR model there is objective function, there are constraints, and in linear programming we learned about the feasibility region. In transportation also we found the feasible solution, but more importantly in linear programming we learned that we were able to find the feasibility region. After the feasibility region, it was quite easy for us to find the answer. If it is below the intersection point, if the two constraints meet at a certain point, this is the intersection point, and if the problem is of maximization, the feasibility region will be where? A or B? If the problem is of A, good, very good, Ravia, very good. If the problem is of maximization, the feasibility region is here. If the problem is of minimization, the feasibility region is here. But in the case of non-linear programming, that's not the case. In the non-linear programming, there is slight difference. So, that's what we have to learn. But in this chapter, for your information, we are not going to solve, because there is no point manually solving complex problem of non-linear programming. We are just going to learn theoretical aspects of the non-linear optimization and see how does it look like, how do those problems which follow non-linear optimization look like. Okay, so we are not going to solve any problem. We will learn 3 examples from actual business, but we are not going to. I'll just pause for 1 minute after the azan is over. I'll start again. Okay. Okay, so we can carry on. Okay, so what we learned so far is that Ibtihal wants to ask something. She has a question. The similarities between linear and non-linear programming is that both of them will have an objective function z, which can be either max or it may be min. They have constraints, and you should always remember the examples that we have done in the linear programming, like for example the example of product mix or cost minimization in the case of fertilizer. And in linear programming we learned that there is something called feasibility region. So who will tell me what is feasibility region? Do you have an answer for this? What is this feasibility region? In simple words, don't look into the slides or notes. How do we define feasibility region? What is present there in the feasibility region? Can anyone answer? You can hear me? When constraints are satisfied, good. That's very good. That is what we learned in the general OR model in the very early classes. But in the case of linear programming, we said that the feasibility region is where the point, the point in which the variable equals no something else. Of course, this is an intersection point, and within this there is a feasibility region. But within this feasibility region, what do we find in the graphical solution? Set of values, set of decision variables, set of decision alternatives. And from this decision alternative, if the problem is of maximization, we choose the maximum value. If the problem is of minimization, we choose the minimum value. So that is the feasibility region. Now, another important point that we must learn is that in the business scenario, in the business situation, many of the systems, when we say systems, it means like system means operations, like for example HR operation. In HR there can be many operations like recruitment, selection, training, so many. Similarly, in the case of marketing, so these are called systems. They are full module of the operation is called system. So the fact is that most of and when we say operations, we know that there will be an objective function, there will be constraints. These constraints and objectives are made up of variables. So these variables, they can be 2, they can be more than 2. In the case of Amazon, we saw there can be 1600 variables, more than 1600 variables. And when they are plotted on the graph, the line observed is non-linear. The graph is non-linear. What does it mean? That in order to solve the problems or find the z values in the real business situations, many a times, not always, there are many cases of linear programming also, as we solved in the case of farmer, as in the case of product mix. But in many cases there are non-linear also, and when there is a non-linear relationship, we will have to use non-linear optimization method. So this was the similarities. But what about the differences? The main difference about non-linear optimization is that you should remember this very clearly, that either the z function or any of the constraints, suppose in the last problem of linear programming we had a z function, a constant 1, constant 2, and in the assignment that you got, you had in one of the problems you had 3 constraints. So if any of them are non-linear, suppose this is linear, but this is non-linear, in this case we will have to use non-linear optimization. That's the major difference, and there are more differences. The second point is that non-linear optimization is more difficult to optimize. Why? That's what we have to learn. That's the main point to be understood in this lecture, in this lesson. So you understood, first of all, what are the similarities, constraints, objective functions, and the feasibility region. All three are common. They are present in the linear optimization and non-linear optimization. But in the case of non-linear optimization, any one of them, if they are non-linear, we cannot apply linear programming problem. We will have to use non-linear optimization, and it's more difficult to optimize. Okay. So now we come to the main topic, the problem. When we have understood where we can apply non-linear optimization method, and when there is a non-linear relationship between the constraints or objective function, between the variables in the constraints or the objective function, then that problem is called a non-linear programming problem. When the method is non-linear programming, I think I'll allow you all to annotate. Change is not constant. Yes, you are right. When the Nada is right. When the graph is non-linear, it means that there is a relationship between the two variables or more variables. There can be more variables also. Okay, it is not like only because we are talking about manual graph. We are taking 2 dimensions, 2D. But that in reality there can be 1000 variables. This is not possible to be done manually, so we use computer programs to take care of this, and there are computer programs, so there can be more than 500,000 variables, and they are all, if there is linear programming, they are all related to each other, and their graph is linear. But in the non-linear, there can be a curve, and that is because as Nada rightly said, the rate of change is not same. Rate of change is not constant. The rate of change is different. Okay. Let's move forward. So let's look at one example from the business. There are 3 examples here to be discussed, and that's the basic focus of this chapter. We are trying to actually, I think I gave annotation permit to all. No? All of, I gave the basic idea about the chapter. Our main goal is to learn some examples. All right, some examples. So you should don't annotate, don't write anything on the screen. You should learn the similarities between LPP and NLP. You should know the differences between NLP and LP. You should know the reason why a graph is linear or non-linear. Okay, and finally we will see 3 examples from the business, and that is all in this chapter we have to do. So let's look at the example number 1 from Who will guess what are we talking about? Which industry is this? These days, we are completely relying on this industry. Our classes, everything is going on because of this industry. Who will guess which industry is this? What business are we talking about? What type of companies are these? Which example? Or industry, we can say industry. What is your guess? In which type of industry we will normally deal with such variables, drop in signal power and distance from antenna? No guess? Can you hear me? What do you say? I said we are looking at two variables. We are looking at two variables. This is one variable V1 and this is another variable V2. We'll go to their relationship later, but I wanted you to guess in which industry do we have these two variables? Type of industry, banking or hotel, tourism, whatever. What do you guess? Signal power? Yeah, you are right. I think I got the first correct answer. Ravia, yes, you are right. This is very much from the telecom industry, and in this industry the major service is to provide telecom communication. It may be internet or telephone or mobile. These are the basic services that the telecom companies provide. And how do they provide? The operation is also simply, if we explain, the operations are to have a receiver. So what they do, there are devices, there is a company which provides the operation, the service to the customers. It has an office. In the office we will have the server. There is a tower which is the transmitter. So what they do, they send signals. They first of all receive signals from the mobile phone. They receive the signal, send the signal to the transmitter. There is a satellite also, and from the satellite it is again sent to the server of the company. From the server of the company it is again transmitted to the. So this is how the operation is going on. Any type of telecom operation, whether it is ATM transaction taking place or phone being working. Right now we are all connected through internet, Wi-Fi, internet, all sort of internet communication. This is normally the main expense, main infrastructure of the telecom business involve the use of transmitter, receiver and senders, and that is one of the major cost for the company. How many antenna should the company install to send the optimal signal power, and this is responsible for good network connection. What happens is, we have faced this, that when we move on highways, we go out of the city, we find that the signal power goes down, and there comes a time when it is completely blank. Why does it happen? It happens because the company does not have the antenna there. The signal structure, the infrastructure of the company is has not been applied to those remote areas. As a result, the signal power keeps going down, and finally it becomes 0. So, the company has to decide. What does the company decide? In this, the Z function for the company is cost or number of antenna that the company should install, because the more antenna you will have, I would have 1000 antenna in a country. Yeah, many examples are there. Aramco is not an example of telecom, but here in this example, any company can be an example of nonlinear optimization if there is a nonlinear relationship between the variables. But here in this case, we are looking at the example of telecom, in which we see there are two variables, signal power and distance from antenna, and when this power, these two variables are plotted on the graph, this is how the graph really looks like. So, this is a real problem. Perhaps this is in the book, or I don't remember, I took it from somewhere else. So, the relationship between variable x1 and x2. So, x1 is the signal power and x2 is the distance from the antenna. When it is plotted on the graph, now since you understand the understand the meaning of nonlinear relationship, it means that if the distance is so what happens is, we are moving on highway. As soon as we move out of the city, when we are just 10 kilometers out of the city, the signal strength goes by 1. When we are 1, so we have 4 signals still. When we are going 20 kilometers out of the city, we have 2 signals. This is a measurement I am just hypothetically using. The companies may be using some sort of other units, but when they plot these two variables on the graph, the relationship is non-linear. That means there is a non-linear relationship. The rate of change of the signal power and the distance from the antenna are not same. Rate is not the same, and that's why the company will have to apply a non-linear optimization method to solve the problem of finding how many antenna the company should have, or what should be the minimum cost, optimum cost of antenna. Why should they calculate this, and what are the constraints? The constraints may be like customer satisfaction or call drops. So, there may be some constraints on these, meaning the company will give instruction to the operation manager, the customer satisfaction cannot be less than this, call drops cannot be less than this. So, within these constraints, the company has to decide, the operations manager has to decide how many antenna or what cost should the company have. Okay. So, this is one example. Now, let us understand the technical part of the solution in the linear programming. What happens is that in the case of linear programming, we had one point of intersection of the constraints, and it was very easy to find the feasible region. But in the case of non-linear program, there are more than one feasible region. So why does this happen? This happens because when there is a curve, we will see that the curve will normally meet not just at one point, but it can meet at many points, and this will result in more than one feasibility regions. And since we are not applying the simple linear programming solution, we are using computerized solution. When we find the solution, we see that the feasibility regions are not one, but more than one in the case of nonlinear programming. So that's one major difference from that the nonlinear programming has more than one feasibility region. So I think it is very much clear. If somebody asks you how many feasibility regions are there in linear programming, who will answer? How many feasibility regions are there in linear programming problems? How many? 2 or 1? In linear programming problems, we have just one feasibility region, and within that feasibility region we were able to find the decision alternatives. But in the case of, Nada is right, we have one feasibility region. But in the case of non-linear optimization, non-linear programming, there are one solution. So what happens is, as in the case of linear programming, we saw that the decision alternatives are found on the feasibility region. So there is a set of solution present in the different feasibility regions. So there, for example, there is feasibility region 1, feasibility region 2, we write it F1 and F2. It can be more, it can be many feasibility regions, because as you go into the real business problems, we find that the problems are more complex, and there are softwares and applications available which solve for us, and they show us that these are the feasibility regions. In each of these feasibility regions, there are solutions. So the solution in all feasibility regions are called local optimum. The solution, the best option in each of the feasibility regions are called local optimum, whereas the best of them, as in the case of product mix, we said there are 4 alternatives and we chose the maximum one. So it was only one feasibility region and we chose the best. But in the case of non-linear programming, there are more than one feasibility regions, and from those feasibility regions we select the best alternative, either the maximum or the minimum, the max or the min. And this best is the global optimum, and the rest, the nearby in other feasibility regions, they are called local optimum or local solutions. This one you have to remember. I gave an exercise to all the other groups in this chapter, to find what is the use of local optimum. So I gave it to the students to find for yourself and share with us on the group, share your findings. What is the use of local optimum? So you have to do your own research and find out and tell us, how is this useful to the managers? Do they make any use of this local solution, or there is no use, it is just calculated? Like, for example, in the case of this telecom industry, they found that in the local feasibility regions, 10 towers, 10 antennas, but in the global it says 12 has to be installed. So what about these 10, 8, 7, the results which are found in the local optimum, are they of any use or not? So this is your question for the assignment, not assignment, this is voluntary. Okay, this is voluntary. You may or may not, depending upon your time, but just for your external reading, the use of local. You don't have to answer now. You take your time and do your research. Local optimum. That's your homework. You take your time later and share your findings after the class, today, tomorrow, whenever you feel like. So how does it look like on the graph? On the graph, when we solve it using a computer program, they tell us that this is at the peak of this is the global maximum, and here all of them, they are giving the local maximum. Now these are 3D pictures. 3D pictures are three-dimensional, so we are looking at the picture from the back side also, whereas this picture, the same picture, when drawn on the graph, it will be like it may be like this. So but to give a better view, the computer normally gives us a 3D. In Excel also, when you draw graphs, there are many options for 3D view of the graphs. That gives us a better idea about the relationship between the variables. So it's showing that there is a global maximum, if this is a maximization problem, there is a global maximum and the local maximum. So which is the best solution? The best solution for the nonlinear optimization problem is the global maximum. So the company will be able to choose this. Manually it may not be possible. Yeah, global is the solution, the final solution. This was not a problem in case of linear programming. There we just found one maximum or one minimum and we were able to solve the problem. But in the case of nonlinear optimization, we tend to have two types of solution, global solution and the local solution, and then we are able to tell what will be the values of the decision variables. So far what we saw, that in the nonlinear programming we have different local and global optima. Optima, or the solution as we technically call optima, it is a plural of optimum. It may be maximum or minimum. An important point that should note is that these optimum are not limited to the extreme points. What do we mean by that? Extreme points. In the case of linear programming, we were able to easily say that this is the point of intersection and everything within. So we call this the intersection point and easily said this is the feasibility region. But in the case of nonlinear optimization, the point of intersection or the optima is not always limited at the end points like this. It was easy in the linear programming to say that the decision values lies here, here or here, end points or the peaks. In the case of nonlinear, it can lie somewhere inside also. So that's why also manually it is not possible to find the nonlinear, find the solution. That's an important difference between the linear and the nonlinear programming. There can be multiple feasibility regions. Obviously, we have seen in the case of the telecom industry, the two variables, distance between the distance from antenna and signal power, that we found that there were multiple feasibility regions. Why? Because the curve is non-linear. They meet at several points when we plot on the graph. So when we have multiple feasibility regions, we have to find the solution from there. So we will get, what will be we be getting? We will getting local optimum and the global optimum, and from there we have to select the best solution, which is the global. Okay, the last point, which the last 2 points are common, and this is something we have to understand in context not just of linear programming, but also in the general OR terms. This was something, you know, I was keeping reserved for the last lecture when we are going to summarize, but we'll see what to do if we can have a summary lecture or something. So OR models are of 2 types, irrespective of what model, transportation or linear programming, non-linear programming. They can be simply divided into 2 types. One is called deterministic and the other is called stochastic. One is called deterministic and the other is called stochastic. Now, linear programming problem, the last one, transportation, that we learned earlier, these are all examples of deterministic models. In the deterministic model, the final solution is same, always the same. Final solution remains the same final solution. Whereas in the case of stochastic model, the final solution changes, is not always constant, it keeps changing. The stochastic model, the final solution keeps changing. Like for example, we saw a problem of decision analysis under uncertainty. Now what will happen, you know, such a problem may be solved using methods of a stochastic model, which fall under the stochastic model. The results are different when even if the inputs are the same. The inputs are the same, the values, the parameters are the same, but in the stochastic model the results may be different. So to make it simple, non-linear programming is an example of a stochastic model, and linear programming, transportation, etc., what we have learned so far, is an example of deterministic. I hope you have noted down the word. It was present in the first lecture, if I am not wrong, first or second. Deterministic model. So you should remember, and if you want to learn more, you can read more on this. What is the main difference between deterministic and stochastic model? For deterministic is LPP, transportation, etc., what we have learned, and non-linear programming, NLP, or non-linear optimization, as you are saying, this problem is stochastic. So how will you say that something is stochastic? Final solution is not the same always. With the same inputs, the final solution is different. Okay, now come to solving the problem. How to solve the non-linear programming? What is the way of solving? So instead of learning about the manual methods, it's important that we familiarize ourselves with the computer packages or the language. I think in Microsoft Excel also there is a possibility of solving, but it's Microsoft Excel is not a package focused on a particular area like research, social researches, or operations research. Rather, Microsoft Excel is mainly about what? Database management, isn't it? MS Excel is mainly about database management, and then they have added some features of modeling also. Do you know that in Microsoft Excel you can do some modeling? You can create financial models, very simple, not very complex. Simple financial models, OR models also. We can do break-even analysis, we can do pricing, many things we can do. We can solve linear programming problem method in Excel, but we cannot use Microsoft Excel exclusively for operations research. But yes, in many of the schools, in business schools across the world, in the courses on computers, they teach. In fact, there are special courses on Microsoft Excel, where they teach students how to do modeling in Excel. And I hope at your level also, at the undergrad level here, you are taught how to do modeling, because it becomes very easy for the managers to do the modeling. And if you are, especially if you are a startup, you are a small business and you cannot afford to buy very costly packages, we can do the modeling ourselves in Microsoft Excel. And there are free softwares also. So that's the first language, modeling. For doing the modeling of OR, we can use Excel. Non-linear optimization is a bit difficult on Excel, but again, this is again for you to explore. These are all questions I give you for those students who are very much interested in OR and want to learn more and want to develop this course as a, or they are very much interested in learning. So you can go and search what role Excel can play in solving of OR, what other languages are available. But when we talk about OR, non-linear optimization solution, we should know that there are two types of languages. Number one, there are languages which help in modeling. Okay, so we will find packages or applications, and I'm sure you all understand that what is meant by package, what is meant by software. So software or applications, these are ready-made packages which are sold by, like the software we are using right now, WebEx. Who will tell me which company has created this package, WebEx? Who will tell me? Did you notice the name of the company who created WebEx? No one? That's a strange. We are all using, entire Saudi, the universities are using WebEx today, and you didn't notice which company produced WebEx? No one? It's Cisco. The name of the company is Cisco, and you must have read in the university news that apart from Cisco, we have our own lecture package, which is Blackboard, and we are also allowed to use Microsoft Teams. These are the packages we are using. So what are these? These are ready-made packages, and Cisco's WebEx is free. What we are using right now is free. We are not paying anything, but for Blackboard we are paying. So there are free packages as well as paid packages. But in OR, when the companies will use, normally the companies would like to use paid packages. Who will tell what is the reason why the company will like to have paid packages, not free? What is the problem with free packages? Suppose you are working and there is a problem of non-linear optimization, STC. You are an STC manager and you want to know the value of Z. You have the same problem that we discussed in there to make profit. What are the main reasons why we should not go for a company will not go for prefer a free package? What are the main issues? They should not go, that's fact. Can use for another purpose. Yeah, you are right. Like very famously, the example of Facebook. There are so many cases of Facebook in record in news that they used our data for without our consent to. So we became actually their tool, their product, instead of So they were selling us the service for free. Facebook is not charging anything, Gmail is not charging anything, but what they did, they made us product and they sold our information to outside companies. So that's a problem with free packages. So when you are working in a company like STC, who are the competitors of STC? Zan is there, all of them are dying for the customers. So what will happen if STC uses a free package and like Microsoft Excel free package? What will happen? These companies can get the information, or they can get access directly or indirectly, and that will pose problem to STC. So what normally the companies do, they buy customized packages. So the customized packages which are sold to the companies, the license is given to them, there is a proper license, security is maintained. So there are two types of languages. One who help in modeling. So what they do, they will formulate the problem. So when we are talking about modeling, just revise what we have done so far in the OR problem solving steps. We learned that OR problem solving are done in how many steps? Number 1, problem formulation. Number 2, after the formulation of the problem, what do we do? Very second lecture, you should keep revising. What is the second step in OR problem solving? Whether it is non-linear programming or linear programming or transportation, we have to pass through these steps. What is the second step after formulation? Modeling. After modeling, no one? You are not studying? What is the next step? After modeling, what do we do? No, not transportation. We select the correct method of solving the problem. That step is called analysis. And after analysis, solution. So these are the steps. So there are softwares who will help us till here. They will make a model, give us the model, and then we can decide on ourselves how to solve. And there are some softwares which help in complete package, they help in the solution. One such yes, you are right, in chapter 3 we did it. So in the model analysis tools, they help in the analyzing. So they will apply the transportation method, non-linear. If it is a package of programming, so they will themselves decide it is going to use linear or non-linear, and then it will solve the problem, give us the solution. It can be applied before or after the solution. So there are two types of packages. Now there is one example we should remember in OR. There are other examples also. One we said Excel, and that may be your homework. You can find more, find the softwares which are available for OR. There are softwares for modeling, for analysis. MProbe is one. There is another software that the engineers normally use. It is called MATLAB. In MATLAB also there are provisions of solving OR problems. But one software that is very famous for solving all types of mathematical programs is called MProbe. So since we are learning about linear programming and non-linear programming, MProbe is a company which has created, like Microsoft and SPSS, IBM, SPSS. MProbe is a company that has created a suite of analysis tools for mathematical programs of all types of programming. So what they do, they give a complete solution. What we have to do, we have to simply provide the inputs, and it's up to you now, because we cannot go into further details. I mean, I am not also very expert, or I'm not very familiar with, I've never used mprobe. So what we can do, you can, if you wish, you can go and check for more details on mprobe. Go to the company website, create some. So maybe these may be the assignment questions I can give you for your in place of the midterm. I will decide, but just for voluntary basis, if you wish, after the class you can just find out what does it do, what is the process of finding the solution. Okay, so whatever information and a brief summary you can discuss on the group. Last part of the lecture, and just 5 more minutes. I think it's quite a long time now, 1:15. So just 5 more minutes and I will stop. 2 examples are there. Again, after the telecom example, there are 2 examples which in which we see that the relationship between the variables are non-linear, and we know what is non-linear, that the rate of change is different. It's not the same between the 2 variables. They are related. There is a relationship. It may be direct or indirect. Now let's look at the indirect relationship, inverse relationship here. Minus, what does it mean? It means elasticity is one concept you have already learned in economics. It means that if you increase the price, what will happen? The demand should go up or down? Down. So this is the relationship between price and demand. Yeah. So when we show inverse relationship, that means inversely proportional, we will have to show it as negative number, minus. So when it says profit as elasticity changes from minus 2.4 to minus 1.8 in increments of 0.1, this is the effect of the price elasticity, which is calculated as in negative function, minus. So minus 2.4 to minus 1.8, it is in terms of negative function. So when it changes from minus 2.4 to minus 1.8, what happens? The elasticity is increasing or decreasing? The elasticity is increasing. Increasing, meaning the effect of, yes, you are right, increasing. The effect of price change or on demand is increasing. So what will happen when the company will decide to reduce the price? This effect of price will affect on the profit also. Demand will increase and the profit will increase. This is purely economic concept, and that is why, you know, when you take operations research, you are already familiar with business maths, economics, everything, and then you come to the course of OR. So you are already familiar with this concept. So elasticity increases. Now profit as price changes from $55 to $110 in increments of 5. This is clear. This is a direct relationship. So what happens is, between the range of $55 and $110, increment is in 5. But after this and before this, it's not in 5. So we will not get a straight curve. It will be a non-linear curve. Also in the z function also, the relationship between demand and price, the relationship is what? Demand is 400. So if it is demand, it is price. Demand is 400, consumers are there, or 400 units demand. Price is 70. But when the demand is 300, price is 80. It is not at the same rate. It is 400 by 70 is not equal to 400 divided by 70 is not equal to 300 by 80. So when we plot this on graph, we will not get a straight line, we will get a curve. So when we get a non-linear curve, what we are going to do, we will have to solve it using non-linear optimization method. In pricing, in the non-linear optimization problem, non-linear programming problem, in pricing, there is another example, there is another extension to the pricing problem, which is the fluctuation of the exchange rate. Fluctuation of the exchange rate. What does it mean? Exchange rate fluctuation. Normally companies, so if you fix a price, you are selling your product in foreign country, you are buying in yen or you are selling in yen. Now when it comes to your company, when it comes to our own country, what will have to be done? It has to be converted into reals. So for this, it is dependent upon the exchange rate, and you know that this is very variable, very flexible. It keeps changing. So when there is a changing relationship, when the rate of change is not constant, there will be a curve. And so again, this is an example where we have to use last very again a very interesting example. Both of these, first one, the telecom problem, was from operations. The pricing, mainly marketing department is involved in pricing, and this last example where nonlinear programming can be applied is advertising response, advertisements. And what we learn is that in the case of advertisements, the major target of the company is to ensure how many people see the ad or watch the ad. That is the major target, see or watch or listen. So it depends upon the medium, and on this basis they pay. So the selection of the media depends upon the exposure, because the advertising theory says that more the number of exposure, the more will be the attention by the, because we normally learn about ADA model in advertising: awareness and interest and desire, and the last one is action. So this advertisement model tells that the consumers, the prospective consumers who would see our ad, only after seeing the ad they will buy our products. So we have to select the channel of communication, wassail lil alanat. So what are the wassail? There can be Facebook, it can be a newspaper, in radio, in television, radio FM, in television, on internet. There are so many medium today. Out of them we have to select the medium which gives us the maximum exposure. Yeah, Twitter are all social media, tawasul ijtimai. So those are the new forms of communication. In each of them, the theory of advertising remains the same. This theory remains the same, and there is another theory. You have studied marketing, right? And you have studied about advertising. There is another theory called Dagmar, which is the deciding on the advertising budget using the advertising response for measured advertising results. What does it mean? It means the same, that when we are deciding about which medium of communication to use, we have to see the result, and the result in advertising is indirect, not direct. So what can be the result of advertising? Increased sales, increased profit, increased awareness. So you can take any of these as Z function. All of them will be, if it is sales, profit and awareness, it has to be max, and if it is cost, it will be Z min. So in the given the constraints, the company has to decide on the Z function, and for this, these are the information. Now look at these two variables, number of ads and exposure. Irrespective which medium they are using, the relationship between the number of ads and, so are they increasing at the same rate? No. If I increase the number of ads, suppose I am using Facebook, I gave on day 1, only one day, exposure is 4.7 million people. but if I give it on 8 days, the exposure increases to 22.1 million. If I give it for 20 times, this is the exposure 50. So, this relationship between number of ads and exposure is not directly proportional. It is related to each other, but when we plot it on the graph, it is something like a curve. And so, here again we will be using non-linear optimization method, non-linear programming. So, these are some examples where in practical business situation where non-linear programming is applied. With this, I will stop for this chapter. This is enough of discussion on this chapter. I will first stop the recording. Yes, so that is done, and